Hello students, today this video is about flip-flop. In our previous video we came to know about combinational circuit. In combinational circuit we came to know about different types of circuit like encoder, decoder, adder, subtractor, multiplexer, demultiplexer, etc, etc. There what we came to know, in combinational circuit we came to know about uh, uh, you give some input and accordingly you get some output. But in flip-flop it happens what, that you give some input and it can store the output accordingly. That is the flip-flop. That means storing means memory. Here in this picture you can see several NAND gates, right, along with one new word called as CLK. Here you can see CLK. CLK is what? Clock. About this clock pulse we will come to know just a couple of minutes after. So what is the difference between this combinational circuit and sequential circuit? The combinational circuit can be able to give the output according to its input, but the sequential circuit is capable of holding the output for several times according to the clock pulse. Now, so what is a flip-flop? Flip-flop is a sequential circuit. Um, it can store one bit of memory, are used in memories, registers, counters, and some other. There are different types of flip-flops like SR flip-flop, D flip-flop, JK flip-flop, T flip-flop. One another flip-flop named as master slave flip-flop that I have not included intentionally here in this playlist. Uh, some other time I will make video on this master slave flip-flop. So what is a clock pulse? Which is very essential for this sequential circuit. The clock pulse or the clock signal is a periodic signal and its on time and off time need to be the same. That means one clock pulse has some tenure or time. We can represent the clock signal as a square wave when both its on time and off time are same. The clock signals are shown in the following figure. Here you can see that uh, in the upper one clock signal is divided into, see, some upper line and some lower line conjugatedly, and the dotted line makes one clock signal. That means how long you are giving this plus 5 volt. This square wave is considered as clock signal. This signal stays at logic high for some time and stays at logic low for some time. See here, first this one, see, high low is staying for some time, then this 0 is staying for the same amount of time, again the 1 is staying for the same amount of time divided, right, and for 0, and in the next one you can see that 1 to 2 1 means two pulses are accordingly going, two negative pulses are going accordingly, one positive pulse is going, one negative pulse is going. See here in the right side picture that the clock period or the clock pulse is means holds for the high and low both. Now the circuit may trigger in the rising edge time, means the upper arrow time, or the whole clock period time, or the falling edge time. That is a different issue. But this is simply a clock pulse, means which used to synchronize and coordinate the operative digital logic actually, right. So I hope you are a little bit acquainted with this clock pulse right now. So what is synchronization? Just let me tell you once. The primary purpose of the clock pulse is to synchronize the actions of the various components within our digital system, right. And after that, after the clock pulse the circuit used to trigger actually. Okay. Difference between a flip-flop and the latch is that the latch does not contain any clock pulse, but the flip-flop contains a clock pulse. the reason a latch to be less stable, temporary memory, and small circuit is because it does not contain any clock pulse. But because of this clock pulse, the flip flop is more impulsive as well as it is more accurate, actually, you can say. Okay. Now I will come in the basic design of uh, flip flop. In the basic design of flip flop, we will see that it comes only NAND or NOR gate, or NAND and NOR gate, whatever. Why? NAND and NOR gates are both universal gates which we can use to construct any circuit design, right? Not only that, NAND and NOR gate are decisive. NAND and NOR gate and decisive means, see, if you closely look at the circuit means truth table of NAND gate, you will be able to see that NAND gate is decisive on 1. The time when you produce 1 to any of the input in NAND gate, you will see that it is providing once it is providing some 0 to any input, NAND gate is decisive to 1. Means once you are providing 0 in either A or B, you will be able to see that the output is 1. In case of NOR gate, once you provide 1 to any of the pin, either it is A or B, you will be able to see the output is 0. That's why we can say that NAND gate is decisive on 0, NOR gate is decisive on 1. Now, after in the next video, we will see how to construct the basic flip-flop like SR flip-flop, JK flip-flop, T flip-flop, D flip-flop. In the next videos, we will see, and keep watching.